So I work in open source. I've been working in open source for 20 years. One of the things that I love about open source is that folk have a problem they want to solve, come together, write code, release the code, and it's available to everyone. So this talk is about how some developers within inside Amazon had a problem they wanted to tackle, which was the problem of authorization, and they created a project called Cedar, which we open sourced last year. So that is the project. That's the talk. Now I'm going to start off. So first of all, I make no assumptions whether you know authorization or authentication. Actually, that's the previous slide, right? So I missed that one out. Previous slide. People get them mixed up. But authorization is the process by when we build applications as developers, how we make sure that principals, users of our applications, multi-user applications, only have access to the resources they're allowed to have access to. And interestingly enough, in the last 30 years I've been working in tech, whilst the authentication problem has been pretty much solved, the authorization problem remains a big problem. And actually last week, someone sent me this. It's now the #1 item on OWASP web application developer issues. So I guess it kind of begs the question as to, if we've cracked authentication, why is authorization so hard? And the reality is that the actual theory of authorization is actually well known. And we've developed over the last 30 years different ways of doing authorization. So we have RBAC, roles-based access control. We have ABAC, attribute-based access control. And we have REBAC, relationship-based access controls, and a few others which I didn't put on here. And the difference between these are things such as role-based being hierarchical, so you can think of a directory structure, Active Directory if you use that. Attribute is where you assign attributes, such as, for example, I'm the author of something, and therefore I can provide authorization against that. And relationship kind of combines this and other things. So the theory is well known, but the reality is that actually implementing authorization is hard. So if we go back 20 years to when everything was a monolith, a piece of code that you could run, there were fewer programming languages, fewer approaches to doing things. This was still hard, right? Because we had to create authorization systems that would allow us to create policies that would allow us to make sure that only the people had access to the resources. We had to figure out how to provide third-party audit access to make sure that we could provide confidence in those authorizations. And we needed to make sure that we built this in a way that it was easy to maintain, as both when we needed to update the code, but also when we needed to update security. And so this was 20 years ago, and it was hard then to do this. But if we go to where we are today, we have sort of microservices written in different languages. If you're building an application that combines Java, Rust, Go, and you have to maintain authorization requests across all those different languages, that makes this problem so much harder. And what developers have tended to do, okay, you don't have to put your hand up if you recognize this, but developers do this a lot. Now, this is a very simple example in Python, but effectively what they do is they iterate in their code the different levels of access required for particular application resources. And some of these can get very, very complex. And I've seen some absolute horrors in my time. And as developers, people put their sort of heads together, think, I can build this. I'm a good developer. I'll build my own authorization system. And I've done it myself, right? And it's super hard. It's super hard for a number of different reasons. The first is when you want to try and model authorization, a lot of complex mathematics is involved, and logic. And unless you are, a master of that, you are going to make mistakes. A key characteristics of authorization is that it's got to be fast and it's got to be reliable, because if you have an application that's being used by thousands or hundreds of thousands of people, and it either goes slow every time you try and do something, or it just is unreliable and crashes, that's not going to be well received by your customers. And then how do you actually make sure that people trust your authorization engine? Because I know that when I built mine, I would not trust, my house, my life on it, right? I just wasn't sure it would actually always work. And so if you're a company, how do you make sure you trust the authorization that you're using? And so this is why these are the problems, these are the challenges that these developers with inside Amazon decided that they wanted to tackle. And they created something called Cedar. So a bit confusing because it's like a tree, but I don't know the origins of the name. We're still trying to figure out what that is. And Cedar is three things. The first thing is it's actually a policy language. It's a policy language written in quite simple language that allows you to, as a, application owner, define policies of who you want to access the resources in your application. The second thing is it's an authorization engine that takes that policy plus artifacts from your application to provably provide correct authorization decisions. And then one of the key characteristics, is it provides analysis tools so that you can start to reason about the policies you've got and start to ask questions such as, do I have too much authorization for this particular principle? Or do I have duplicates within my authorization policies? So I'm going to go through all these three things. And the first one is the authorization language. So this is policies. So a policy defines what users' principals can do what actions against your application resources. It's pretty straightforward. It's a very simple example there. And what it allows us to do is if we use the same code example from before, it changes and simplifies the code from all that boilerplate code to just one function call, which is authorized. And so this is how effectively this can make your applications much simpler. And irrespective of the language you're in, it's always doing the same thing. Now, when you write these policies in Cedar, there are kind of three things within the policy. The first is the effect, which is effectively allow or deny. The second one is the scope. So kind of based on what you want to do. So a combination of the users, the actions, and the resources, what you want to provide authorization for. And then the final one is optional, which is attribute-based, so condition. So I might want to give, say, John Doe access to manage photos, but I only want to do it if they are logged in with MFA. Okay. And so this is what they look like. Okay, when you actually write these. So permit is your actual policy. We have the optional in purple, the conditional, which is the when clause. And one of the things that I always get asked, is why do we separate the two things out? Why do we do it this way? And the way that we do this at Amazon is that we create something and then we get some customers and we say, look, this is what we're thinking about. What do you think? And they told us, because we gave them a number of different approaches, and they said they wanted this because it was simpler to read. And this is important because one of the things we did before we created this is we looked at what other open source projects out there existed that we could contribute or work with to do this. And the main one is OPA, Open Policy Agent, which uses Rego. Now, we looked at this, and it's very flexible. It's a very flexible policy language, which you can use for infrastructure, you can use for application authorization. However, what we found, and what we found speaking to customers, is it was just too complex. You can compare these two policies that do the same thing, and when you've got lots of different policies, it actually makes it significantly harder. So effectively, we decided that whilst OPA is interesting and we support OPA and other things, it wasn't going to do what we needed. So that was the kind of catalyst for using or creating Cedar. But of course, when you create policies, your policies need to reflect what your application resources do. So one of the key parts of when you're using Cedar is you have to model your application. So in the examples that I'm going to be showing, you'll see action equals something. In this case, I've got the demo I'm going to show is a photo sharing application. Now, if you think about the characteristics of a photo sharing application, they're going to be things like add photo, create photo, manage photo. There might be some other things such as site admin, that kind of thing. So every application is different. So you define your application characteristics in a schema. And the schema is what allows your policies to, or you can define stuff in your policies about your application. So in this example here, I've got view photo. Cedar knows about view photo because it's defined in the schema. So I mentioned that there's two effects, permit and deny, or forbid. And the scope is effectively the kind of resources that you want to access. Now, you can either be explicit in the resource, or in fact, any of these. This applies to principles, resources, and actions. So in the top one, we've just got action, which means that within your schema, all actions are permitted. In the second one, we've got an explicit, which is deny photo. So effectively, what this means is that unless you meet the criteria for delete photo, you will be able to do all actions apart from delete photo, because delete trumps permit. Now, in the examples I'm showing, including in the code, I use very simple, easy to recognize names, but you wouldn't do this if you were doing this in reality. You would use unique references, because there's always, especially if you've got a user ID, users have this habit of changing name, and you don't want to hard code that. So basically you create an abstraction, an entity ID, UUID, that references your user, and then you do that in your application logic. Now, the conditional clauses are very flexible, but they're not super flexible. And this is, again, one of the reasons why we created Cedar, is that there's always a trade-off, okay, in performance characteristics and reliability characteristics versus what, developers want. And so there are a few operators you can use. So in that respect, it's much less flexible than things like OPA. And you can group things together. So if you want to, for example, define one action or one principle, you can do that through lists. For multi-tenanted use cases, you can actually define namespaces as well, where you can actually implement multiple policies against different namespaces. So that's a very quick overview of actually what policies look like and the main characteristics of policies. So how does it actually work? So on the left-hand side, we have our policy. We have our application information. So the schema, and then the entities within our application. So the users, things like that. And then we have context. So this is the session. So it might be things like, I'm logged in, my IP address, my location, that kind of thing. So this is input into the authorization engine. And then the authorization engine will take that input and give you one of three outputs. I know it says only two there, but there's three outputs. One will be allow, the second one will be deny, the third one will be an error. And the way that the evaluation engine works is through this model. So if there's an explicit policy match, you will get access. If there's no policy match, or there's an explicit deny, or there's a combination of both, you will not get access to your resources. So we default in no access, which can be a pain when you're writing these things, because you realize every time you're writing your applications, you don't get access, and then you realize why. But one of the questions you may be asking yourself is, how can you actually trust? I talked about building your own, okay, and how it's really hard. So how can you trust something like Cedar, right, versus your own code? And this is where we look at how, within Amazon, we've got a research team that is looking at how we as an organization can use automated reasoning. Are people here familiar with automated reasoning? Put your hand up. Okay, I'll do it. I mean, I'm not an expert in this, right? So I'll give a very, very simple example. But at school, I remember still, working on Pythagoras theorems and calculus, where you had to do, for example, proofs and all that kind of stuff. And this kind of works in a very similar way, in that you define you start off with a specification. So in our case, what are the characteristics, or what's the specification for an authorization system? You then model these. We use modeling tools such as Daphne and Lean. And these are very expressive languages that allow you to create digital proofs in the same way as you used to do in mathematics for Pythagoras. But they also provide tools that allow you to test it to make sure you've got characteristics like correctness. And then once we've got that, we then implement that. So as an example, okay, this is what one of the specifications for an authorization system looks like. So this is actually any explicit deny in any policy logic overrides any allows, right? Very simple. And so taking a language like Daphne, okay, you can start writing some code that says, okay, well, this is what we want to do. But when you think about this, this is actually not low enough detail, right? Because what we need to do is when we're using formal reasoning, we have to look at the chain. Okay, so we want evaluate logic. Evaluate logic needs a match deny. Match deny requires match statement. Match statement requires this, etc. And we get down to the lowest level. And so what we end up having to do is create, again in the tool, logic that we can use to prove a string will always ignore case. And so rather when you're doing, when Pythagoras, did a squared equals b squared plus c squared, we have to do that for every single part of the code. So this thing gets really, really big, very, very large. So this is the difference in when you're applying formal reasoning in code. So it takes a long time. And it took 3 years, for example, to create all of the stuff that we did. So the question is, if it takes such a long time and it's so complex, why do it? So the reason why we do it is that, first of all, it's the only way we can provide proof of correctness in the systems we build. Okay, so in this instance, it's authorization, and it's a really important characteristic to be able to rely and depend upon the fact that if you do an authorization request, it's always going to be right and correct based on the policies you create. But I think the more interesting things about why this is useful is that it allows you to do things that you can't ordinarily do. And I think that I've got those coming up, actually. So one of the things we want to do is we want to make sure we evolve authorization code over time, right? So we want to make changes, we want to improve it, we want to add new features. If we don't have a way of proving the characteristics or the correctness of security outcomes, that process is very hard. So think of it as like unit tests, okay? But once we've got proofs that allow us to check that the authorization results are always true, we can go faster, we can make changes, we can do optimizations. And so we use it, for example, when we built the new IAM authorization engine, which processes 1 billion requests per second of authorization requests. So at this scale, okay, if we want to make changes, we need to make sure that we make the right changes. And so this is where, effectively, formal reasoning is really the only way that you can combine that proof of correctness with the ability to then move faster. And so this is how Cedar was developed, using a tool called, or a methodology called verification guided development. And effectively what this means is we took and we created, using lean initiatives, not Daphne, we created from specifications some working code. Okay. Now, we can't run that code in production. It just doesn't work at scale, right? So we then built it again in Rust, memory safe language, very performant. And we built it again. But we don't have the same tools in Lean that allow us to prove the correctness of the code in Rust. So we know that the code will always give authorization requests in the Lean implementation, but we cannot say the same thing about Rust. And so this is where the differential testing comes in. So we take basically inputs into both of the code bases that are created. So we take a policy, we test it. Now, if the Rust code is right, then it will give us the same output, so allowed or denied or error, as the Lean version. Right? So we can test the code, but what we want to really do is test it literally hundreds of millions of times using fuzzers to create random policy inputs. And as the output of that, we get, confidence that the Rust code is equivalent to the Lean code. And actually what happens is that every time we do a release, so a new feature gets added, we go through this process. And we were surprised how many bugs our Rust code generated. And what I mean by bug is the output from the lean versus the output from the Rust was different. And if that's different, then you know you've got a problem, because we know the baseline is the lean implementation. We know that's provably correct. But if our Rust code differs, we've done something wrong in our Rust code. And so we do that until we get no errors, and that means we can then do a release. If you're interested in that, there's a blog post. I've got a QR code at the end, which will have all the links and everything. So I've talked about what a policy is. I've talked about the policy authorization engine, and the next one is actually, as an organization, you want to now basically reason about the policies you have. And typically this is because you want to check for things like equivalence assumption of access within the users you have. And so there are tools, CLI tools, that allow you to do that. So you can basically ask questions, okay, does this principal have this access? And you can do it through automation, which means you can now start to implement modern application development techniques to test if your users have got too much access or if you can simplify your policies. So I want to show you actually now how this works. The code is available on my repo. It's Python based, even though the actual engine is only and will only ever be deployed in Rust. Python has a thing called P3O, I think it's called, which allows you to have bindings, very high performance bindings with Rust. So that's the code. And I'm going to take a very simple application. It's a photo sharing application, which you might typically have a bunch of users, groups that want to have access to a photo album. You might have an admin, that kind of thing. And I might want to model some kind of typical authorization requests like this. So I talked about modeling your application. I'll show you what it looks like, but this is the schema of my application. Okay, so I've got users, I've got groups, I've got photos, I've got photo albums. It's a deliberately very simple example. And what I will do is I will take the stuff I've got in my schema. I'll take the entities, which are things like my usernames, the album names. I will put that together with my policy into the authorization engine, and it will then give me whether this resource or this request is allowed to proceed or not. So I'm going to sit down and show you this stuff, which you can run yourself. So I've actually already started the Python application. I'm not going to bother showing you that because it's pretty boring. But I do want to show you what the code looks like. So let's have a look. Manage photo. Now it looks okay up there. So this is deliberately verbose, the code, because I want it to make it readable. You wouldn't typically do it this way if you're coding the application yourself. And also this is Flask application. So if you're not familiar with Flask, it's a very simple tool. You define a route, and then in this instance, I've got login required. I then define the function of actually what executes when you access that route. And here I've got my action, my resources, and my user, and the request. And then effectively I read in my policy, and then here is the authorization request. So I do authorization result. The diagnostics basically just outputs the policy that was invoked. You wouldn't, again, necessarily put that in there. And then the actual logic is, if it's deny, then generate a 403. And if not, then show the page. And that code is the same for every single function we have in there. So if we had our own application, like I've done this for Java as well in a Spring Boot application, you could have a really simplified application where, you might have, a front end React application that hits, Java and Python. It's both using the same policies. So one policy you have to manage, but the authorization logic is still the same. It's still using Cedar under the covers. So this is what my schema looks like. It's very difficult to see on this, but you can kind of see the kind of thing that that you're effectively showing how your application looks like. And at the moment, these are my policies, and they're all at the moment grayed out. They're all disabled, which means if I access my application, so this is the application. Let's hope it works. So this is the application. It's very simple. If I log in, I'm going to log in as Jane Doe. So again, I can access the home page, but in theory, I shouldn't be able to access any resources. And as expected, I can't. Let's log out. So how do I change that? How do I let Jane have access to the resources? Well, I can define a policy. Now, there is one policy here that I want to specify. So where is it? Is it this one? It's this one. Okay. So this is a very broad policy, and I wouldn't ordinarily give this one to Jane, but I want to show how it works with regards to the conditional. So this allows basically permission, access to any user against any action. So those are the actions against all resources where the owner or the resource owner is the principal. And in my entities, I have defined this user Jane Doe, and she is the owner of one of the photo albums. So she should have access from this policy to access now photos. So that's now. So I can access public photos and I can do manage photos, but I will not be able to access those. Now we've got John Doe, who isn't the owner. I don't think he's the owner anyway. Oh, I've got that wrong. Let's see what he can do. So he can't see anything. So even though he's in the same group, because he's not the owner of the resource, he can't do that. Now I can log in as admin. There's an admin policy. Where is it? There we go. And this allows basic admin to have access to everything. There we go. Now, in the example policies here, I've actually provide other examples how, for example, you can tie this into things like if you've got MFA enabled to provide additional ways of enriching policy stuff with the request you've got. Now, this is written in Python, but what if you don't want to use Python? There's this thing called Cedar agent. It runs as its own process, and I can basically now, I've actually got all these, where are they? Yeah, I think they're here. So I can actually now show you so it's all done through Swagger. I can actually do things like get policies, execute, and it will show me the policy. I've only got one policy at the moment. So you can use this and then use just standard API calls. So using, obviously I'm doing curl the command line here, but let's have a look if this one works. So allow access, so it's allowed. And if I go back to the actual thing, you'll see that basically the outcome has succeeded. So this is where, for example, if you don't want to use, or if you're using an esoteric language that's not supported by the bindings, then this is how you would use that. So that's the demo very quickly. I just want to show you how it actually looks like. Now, the research team does a lot of papers, and I mentioned OPA before. Some of the design decisions we took around Cedar, and specifically design around policies, has actually turned out to be very, very wise, because we can see that tail latencies as you scale up for other authorization systems start to go up, but Cedar remains flat, which means when you're doing like billions of requests per second, then the performance of Cedar is always going to be good. So effectively, Cedar allows you to be performant, it guarantees correctness, and you can actually review the policies. There's a command line tool that allows you to automate this through the command line. So what we see people now starting to implement authorization through their CI/CD pipelines. So now you can do it and treat authorization as code, which is something that you've not traditionally been able to do, and use the validation CLI to guarantee the policies meet your test cases and you're not accidentally giving access to people you don't want to access. So there's a number of different ways of getting started. This is a really good repo, Awesome Cedar. It basically shows you both the official bindings, language bindings to Java, I think Ruby, as well as the community-driven ones. The ones I showed you are community-driven ones, the Cedar one, sorry, the Python one, but provides also resources of how to get started. And I showed the Cedar agent running, so you can see that there. Now, one of the questions I get asked, okay, is that everything I've showed you is running locally and you can do yourself. But a lot of people start off doing it themselves and then realize that actually, you know what, I want someone to do it for me. So there are companies like Permit.io, StrongDM, or ourselves, Amazon, that provide effectively a managed service of Cedar. And that's pretty much my talk, really. So if you want to learn more, there's an online workshop which you don't have to do anything, you don't have to install anything, you can just run it locally. And it's got a policy playground so you can play around with it. There's a GitHub repo that allows you to get all the code. And there's also a very active community on Slack that allows you to get involved with that, because it's still a new project. There are still RFCs being created that are changing what features this Cedar is going to have going forward. So I think we're on 3.2 at the moment, but there's already about 4 or 5 RFCs. And these RFCs are how open source projects work, right? So as a community, people are using it. They say, wouldn't it be great if we had this? So hot topics are typically what operators they want to be seen in policy, so that allows a much richer experience when creating policies. If you want the slides, there is a survey to do. You'll get it's a small amount of questions I ask, and then you get in return the slides. And I think for the first 5 you get a $25 AWS credit code as well. So with that, thank you very much. And I've got time for have I got time for questions? Yeah, I've got time for questions.
Hi, thank
Hello.
you. Great talk. I noticed you said that the lean implementation was not used in production.
Correct.
Could you elaborate a bit more?
So the characteristics of what you want to run in production, okay, if you think about it, it's got to be performant and it's got to be robust. Okay, those are not characteristics that the output of Lean or definitely or TLA give you. What they do is they provide tools to guarantee correctness or prove it. So they create resolvers and they provide tools to effectively guarantee that you are or you meet the requirements of your specification. So you wouldn't use that in production. Right. So the question is, then you've got to then implement something else, right? So for AWS, we are now moving. We're about 80% Java, right? But we are now moving more to Rust, and especially critical systems around security are being built in Rust. And so effectively, what that means is that we'll build it in Rust, but Rust doesn't have those capabilities, right? So how do you make sure that you can have confidence in your Rust code? And there's no way, right? There's no formal reasoning resolvers, which is why we came up with the differential verification methodology. So it's not. I mean, you can run the Lean implementation, standalone on your laptop, but you would not want to run it in production. I mean, there's no. Lean or definitely don't have, for example, memory. They're not type or memory safe, right? So who knows who could potentially compromise that?
I was just wondering, could you have something that would take Lean as it is and convert that into Rust code?
So those tools do have that. So I'm not sure about Rust, but there is a transpilation into Java, right? The problem is what we see. I mean, I don't have it here, but when you look at the code it generates, the Java code, it's dodgy. Well, it's not dodgy. It's just, well, no, it's not that. It's hard to read, right? Typical transpilation is that it doesn't think about an end user. So it actually works okay, but the way they define, for example, variable names, like a sort of 2 pages long, that kind of thing. So so there is a presentation actually we gave about 4 or 5 months ago that actually walks you through the code. And what it looks like when it went through that transpilation process. I don't think at the moment it supports Rust as a output only Java. a lot of these tools actually tend to favour Java, which is fine for us because we tend to write that. But because we're now going to Rust, we now then implement that through Rust.
Thank you.
That's right. Any other questions? No? I can't, I've got the wrong glasses. I'm not sure if there's any questions up there. Okay, so yeah.
Just a quick one, because I noticed that when you were doing the example, you didn't actually have to reload Flask when you updated the configuration. Is this just like a testing, or is that actually like...
So,
well?
Yeah. So what I did for the root, if you saw, I'll show you the code. So in the code, so the root, okay, you can see that I actually load. I've got a function that reads the policy. You wouldn't normally do that, right? I am only doing that because to make the application easy to show how it works. I mean, you could if you were doing this in production, bearing in mind this is typically done for systems at scale. You would profile this and see what the performance impact of that was. But typically it will be either a background reload task that maybe happens once an hour, once a day, or if you wanted to, because your application load is not that high, you could carry on doing something like this. So yeah, so this was a deliberate reason just for the purposes of demoing. Yeah, in the same way that this code here is very verbose. It's designed really to show the way you would do it. I mean, if you were implementing it, you would do it a lot better than this. Cool. That's all right. All right. Well, thank you very much then.